morning, Math 8. This is Mr. Bainey, and we're going to take a look at, hey, what's up, Math 1? We're going to take, hello, this is Mr. Bainey. Hi there, let's take a look at lesson 18.2, which is proving figures are congruent using rigid motions. So rigid motions is something that we've been working on last lesson and also in the last module in module 17. So remember that the rigid motions include three types of transformations, and those are reflections, translations, and rotations. So if we start with a pre-image and then we have an image, that means we've got two different figures, as you see here in example A or part A, that if we start with this one and then we end up here, is there a way we can do a reflection, translation, or rotation to get from here to here? Or a sequence of those, right? Last lesson, we learned how to do sequences of transformations. So we're going to be applying that here. And we're almost working backwards because we have our pre-image and our image, and we're sort of filling in what's happening in the middle. Congruent, that word is something that I've talked about in class before. And congruent, in this sense, the definition is just, it's congruent if we can use rigid motions to go from one to the other. Okay, there's another definition of congruent that I'll talk about in one of the future units, but we're not going to worry about that other definition for now. Just can we do reflections, translations, or rotations to get from one to the other? So I just want to quickly show you on this part A and possibly on the part B what that looks like. So let me draw around the pre-image so that I am able to move it around. There we go. We see quadrilateral ABCD is outlined in red. So you're going to see me move that around. Notice I am not turning it or flipping it or anything. This is called a translation. And as you can see, if I take this and I slide it over here, it perfectly fits. Well, I say perfectly, but I didn't draw it perfectly, but it does translate directly to the new quadrilateral HEFG, which means these two quadrilaterals, these two figures are congruent because all I have to do is translate to get to here. And what you want to start thinking about is how can we describe that translation? Remember translation, that's going all the way back to 17.1. We used vectors. So something that looks like it's in the form of this, using these brackets, or we can also draw the vector. So like going from point A to point E, this would be our vector if we drew it. Let's take a look at the next graph. And think about if I started at quadrilateral JKLM, how would I get from that one to the other one, P or NPQR? Here I have it outlined in blue. If I were to take this shape and try to move it around, you can see there's no way I can really overlap it perfectly. So it's going to require me to do some rotation or flipping. If I rotate it like that, looks like I still can't really get it. Okay, so this would be a perfect opportunity for you to use your transparency. That's sort of what I'm trying to do here, is just trying to make it fit. And so let's try to flip this and see if I can get it. So there, I've flipped it sort of vertically, or I guess along a vertical line like the y-axis. And if I moved it down here, you see it still doesn't quite fit. But now if I rotate it, I can get it to actually fit very, very nicely. So that one actually took me two different rigid motions. And because of that, these two figures, this one and this one here, are both congruent. I had to flip it. Let's see if I can show you that again. I had to flip it so it ended up like this. sorry, is more like this. And you can imagine that there's this vertical line like this, and that's how I reflected it. Or if I moved it over, you can probably see it a little bit easier like this. Okay, that's a reflection. Reflected that and then had to rotate it. And you can think about rotating it around a certain point, and that doesn't quite matter so much here. It's going to matter once we start actually doing this in the coordinate plane. But I'll probably have to rotate it and then possibly even translate it if I have to slide it over, right? Because it depends on which point I rotate it around. I wasn't very, very descriptive with exactly how I'm reflecting and rotating, but you sort of get the idea. Is we're trying to go from the pre-image to the image in some way, but only using the 3 rigid motions. On the bottom page 898, we have a couple examples. I'm going to do one of these, and I'll have you do the other one. So number 2, we want to use the definition of congruence to decide whether the 2 figures are congruent. Recall that the definition of congruence is, can we go from the pre-image to the image by way of rigid motions, one of the 3 rigid motions? And if so, then they're congruent. But when it says explain your answer, that means we want to actually explain exactly what's going on. You know, like how are we translating it, or how are we rotating and reflecting? So let's go ahead and do number 2. Let me trace around this again, like I did with the others. This probably isn't really necessary because we only need to do one rigid motion here. Some of you may already see it. If I just take this and move it down here, translate it, that's not going to work. So it does look like it's a reflection. So let me do my reflection. My reflection only allows me to do it kind of through the center of this shape. So it's going to just let me do it that way. And I know that if I were to reflect it over the x-axis, right, I would end up with that red shape now. Okay, that would be my line of reflection. And therefore, these 2 figures are congruent. Okay, you can see that it overlaps it pretty well. And let me write down what the congruent statement would look like. This is something that you're going to have to do at some point. So A, B, C, D, figure A, B, C, D is congruent. This is our congruent symbol. And the order of these letters is very, very important. So we want to make sure that A, the first letter here is A. So the first letter has to be the image of A, right? Meaning A is right here. When we reflect it over the x-axis, that's W. B reflected and became X. C reflected and became Y. Luckily, this is in alphabetical order, so nothing too crazy here, but that would be our congruence statement. Okay, let me write that down. Again, this is something you will have to do a lot of in the future, in the near future. Congruence statement, anytime it's asking for that. And let's actually describe this transformation. We did a reflection, and don't just say reflection, you have to say how it's reflected. It reflected across the x-axis. You can also write the rule. It doesn't say that in the directions, it just says explain your answer. So if you can just say they're congruent because it's a reflection across the x-axis. That is plenty enough of an explanation, but reflecting across the x-axis means that this is the rule, right? Which is not a bad idea to get more familiar with these if you haven't worked with these a whole lot. Go ahead and try number 3 before you see my solution. Please pause it, but try to figure out what type of rigid motion if they are congruent. And one thing before I actually put the solution up, I forgot to mention what to look for in terms of your pre-image and your image because it's not very clear. They don't use the way we normally name our pre-image and image. They're not doing that. They're not using the prime symbol. So in this book, they sort of made um, the pre-image in a sort of black, darker outline, and then the other one looks a little more gray, right? Not as dark. So that's always going to be the image, and then the darker one is the pre-image. So just look for that when you're trying out some of the practice problems later on. Okay, if you haven't paused it yet to try this out, please go ahead and pause it right now, and you'll see the solution show up here very shortly. Here you see one of the solutions, and this is just using only one rigid motion. This is probably the most efficient way. It's okay if you come up with something different, and in some of the other problems or the examples that you'll see, there are multiple answers. So let me just show you how this one works. So we have the triangle LKJ that's what I named it. If you put JKL, that's fine, or whatever order you put. Just remember that the order of the other letters has to correspond, or the pre-image points or letters have to match up with these ones in the right order. So if I reflect this triangle so that it's facing the other way, you can see that this triangle is exactly the same distance away from this line of reflection that I drew. This line is the line x equals -3 because all of the points on this line have an x coordinate of -3. So that's how I get that. If you did this a different way, meaning one of the examples is if you reflected this thing across, let's say across the y-axis, you would end up with this triangle right there. Well, how do I get from this blue triangle over to my image? Well, I need to do a translation. I just got to slide this thing over. Let's see how many times. It would be, it would be 1, 2, 3 times to get there. So it is possible if you want to use multiple transformations, but sometimes there could be a more efficient way. So if you did put reflect across the y-axis and then translate left 3 times, which we can write rules for. So that is an option. Reflection across x equals -3, there isn't really a coordinate rule that we can put down, so I'm just going to leave it like this. And the last problems that we're going to look at on the bottom of page 899, these ones are going to require that you use multiple transformations or multiple rigid motions. So you can see it tells you that they're actually congruent. So you know that there is a way for you to use translations, reflections, and or rotations to get from one to the other. And it tells you find a sequence of rigid motions. A sequence means you're going to be doing more than one. And also, it wants you to give coordinate notation, meaning it wants you to give the x comma y with the arrow and then figuring out what the rule is. So make sure you do that when the directions call for it. So I'm going to do number 5. Number 6 has more points to it. It's a little bit trickier. So be careful with that one. And like I said, there's multiple answers to these. So what I come up with, if you come up with something different, doesn't necessarily mean that yours is incorrect. Okay, so number 5, it tells us, or it gives us this congruence statement saying that JKLM is congruent to this one. This is the darker one, that's our pre-image. The one on the bottom is the image. So let me go ahead and trace it. Here's a little hint to doing these as well. In case you're looking for some sort of, steps or a process that will work just about every single time. If you can transform this, if it's not the same orientation, right? If it's not facing the same way, then you know that you're going to be doing at least a reflection or a rotation or both. So my suggestion is to make it the same, facing the same way as the image, and then do your translation at the end. The translation is you just making that final adjustment to try to overlap it. So I'm going to do a reflection. So if I reflect this, and I could reflect it over the x-axis, so that's what I'm going to do, and it'll look like this. It'll be right there. And with that, you can already see that it is facing the same way, right? This short side right here, and then the WX right here, and then the long side is here on the bottom, YZ is down here at the bottom. It's the right orientation that I needed. If I went back and let's say I rotated it. If I tried to rotate to try to make it match up, right, you'll see that this is not going to be facing the right way. It'd be like this, right? This, which is not what we want. And you can see that from there, if I did want to rotate it in some way, I'm not saying it's going to go there, but if I rotated this thing 180 degrees, I think it would end up here. And then I could reflect it from there, right? Reflect it across the y-axis and then do a translation, right? So there's another possibility, right? But that seems like it wouldn't be as efficient as what I had tried before. So let me go back to reflecting this thing, and then let's figure it out from there. So this is a reflection across the x-axis. That's our first one. And I'm going to write down the rule at the bottom. So we start off with x comma y, and reflection across the x-axis is x comma negative y. And then I'm going to do another transformation. So if you remember, we did sequence of transformations in the last lesson. This is how we wrote a sequence, is with we just put an arrow after the last one. And let's figure out how I'm going to translate this. So I'm going to go, let me ungroup this first of all. Looks like I'll have to translate it. Let's see, left 1, 2, down 1. So I went left 2 and down 1, and that'll look like this as a rule. Left 2 means x minus 2, and down 1 means y minus 1. So I translated it. Here's my description. Translate left 2 down 1. And that's it. So I have my description of my sequence of transformations here. I have my rules right here. Try number 6. Again, it is tricky, but make sure you have down the rules and the descriptions. And in a few seconds, I will have the solution, or at least my solution, what I come up with here. Let me walk you through how I came up with my solution for number 6. So I took this shape, what I have outlined in red. And by the way, here's a tip. Because of the congruence statement that it gives you, you know that A is the preimage and it goes to P. So I want to make this go here, and you want to make B go to Q, and so on. So what I did was I reflected it across the y-axis, as you see down at the bottom. So across the y-axis would make it look like this. Then I went down 10. I'm going to tell you a mistake I made on number 5. I just realized as I was writing this. So if I go down 10, it'll bring me all the way to this shape. And Here's the mistake I made. Let me go back to number 5, but definitely take a look at my rule that I have here. I've already described, I sort of walked you through how I thought through and went from the pre-image to the image using my description. I miscounted on number 5. I apologize. Um, the scale here goes by twos, so that kind of messed me up. Instead of going left 2, it should have been going left 4 and then down 2, which means in my rule, it should be x minus 4 and y minus 2. Okay, that's it for this lesson. Thanks for watching. Hope it was helpful. Have a good day.